Today we're doing 3.1, end behavior in polynomials. It's on the very outsides. Is it going up? These are either going to shoot up to positive infinity or down to negative infinity. And there's certain things that determine which way it's going. Okay? Before we get to that, I want to define what a polynomial is, so we kind of all have the same definition. It's going to be the sum or difference. So you can be adding or subtracting is what that means, right? The sum slash difference of several terms that contain different powers of the same variable. The terms are the parts that make up the polynomial. So for example, and I think some of you grouped your polynomials when you did the grouping, you did it based on the number of terms, okay? F of x equals 5x cubed minus 6x squared plus 7x plus 2. This would be a polynomial. It's all, adding or subtracting a bunch of terms that are that have powers of the same variable. So it's x cubed, x squared, x to the first, and really this is 2x to the what? What power is on this one? X to the 0. What's x to the 0? 1. So, and we usually put them in descending order. They don't have to be in descending order, but we usually put them that way. That's kind of just general form. Okay, this would be a 4-term polynomial. It has 4 terms. 1, 2, 3, 4. Okay, the degree, so here this has 4 terms. The number of terms doesn't have anything to do with the end behavior, okay? But the degree does. The degree is always your highest power. And usually we put it first, but it may not be first. So you got to look at it. So whatever that highest power is what you're going to call the degree. So what's the degree of this polynomial? 3. And the word for that, if it's a third, it's cubic. Cubic. Quartic is 4th degree. Q-U-A-R-T-I-C, kind of like a quart, but quartic is a 4th degree. And then after that, we usually just say 5th degree, 6th degree, 7th degree. Okay, and of course a squared's a polynomial too, is a quadratic. Okay, so there's names for those first several. All right, so what we discovered yesterday is there's 2 things that affect the end behavior. It's both the degree and then whatever that term is, which usually we want to put it first, but it may not be first. You got to find it. The coefficient in front of it. So, and then there's 2 different things. Is the degree odd or even? So it's the odd or even part of this, and then it's if this is positive or negative. Okay, that's what's going to determine the end behavior. So we're going to go through now and kind of summarize this end behavior. If you know the parent graphs that we're going to draw right here, if you know the parent graphs, then that'll help you remember if it's going to go high, high, low, high, etc. Okay, we know really well the parent graph for the even degree, that would be x squared. We know that graph, right? So if it's, this would be for even degrees. The end behavior for all even degrees. So if it's squared, if it's to the 4th, if it's to the 6th, if it's to the 8th, if the degree is even, and again the degree is the biggest power, right? So just if the biggest power is even, then it's going to function like y equals x squared. And we would say that the end behavior here is that it starts high, ends high. Starts high, ends high. We're going to write starts high, ends high. Okay, high, high. What causes it to go low, low is if I put a negative in front of that x squared, right? So if I make it y equals negative x squared, going to flip it upside down. And we say this starts low, ends low.
Is this still an even degree?
So if it's an even degree, okay, even degree will do the same thing. So right off, you know, even degree, it's going to go either high, high, or it's going to go low, low. Then you look at what's the number in front of that even degree. If it's positive, it's going to be high, high. If it's negative, it's going to be low, low. And it kind of makes sense because whatever the biggest power is going to rule ultimately in the end. And if you take a negative and you square it, that's going to shoot it up to positive infinity. You take a positive and you square it, it's going to shoot it up to positive infinity. So it's high, high. But if you multiply that whole thing by a negative, it's going to cause it to do the opposite. Go low, low. So all your even degrees will do that. They'll either go high, high, or low, low, depending on the leading coefficient. Okay? All your odd degrees function like the most basic odd degree is y equals x cubed. Okay, this is a new parent graph that we need to know. I like to call it the disco curve. It does this. This is what just y equals x cubed looks like. Sorry, I was off. Zoom out a little. It's on this poster over here, which I'll have to cover up when we take this test. But this really helps if you can get this memorized. Then what you'll know, okay, if it's an odd degree and it's a positive leading coefficient, it's going to start low, but it's going to end high because that positive being cubed is going to win. Ultimately, at the end, it's going to be up at positive infinity. Okay? But if I put a negative in front of that, it's going to cause that to flip, right? And so switch it and put a negative in front. Then it's going to start high, and it's going to end low. Why would it start high? Why? I mean, it's negative. Why would it start up there? Any ideas? Like, what are your numbers over here? What kind of numbers would we be plugging in for x? Negatives. And when you plug a negative in and you cube it, that actually stays negative, right? But then you multiply it by a negative, and that makes it positive. So you end up kind of with a double negative thing going on here. But here then, these would end up being negative. So that negative x cubed is going to end up pulling it down to negative infinity. Okay? So I kind of remember it ends whatever that leading coefficient is. So if this leading coefficient is positive, it's going to end positive. If its leading coefficient is negative, it's going to end negative. Okay? And it's going to do opposite. So we say here it starts low, ends high. And we say here it starts high, ends low. Okay, so you got to get that part memorized. I feel like the odd, for me, it's pretty easy. Odd's going to do the opposite. Okay, even does the same thing, right? But odd's going to do the opposite. It's the disco curve. But it's going to do the opposite here. And so then how do I remember low, high? Well, you can either picture that x cubed graph, okay? Or if that's not helpful, the positive is that's where it's going to end if it's positive, okay? If it's negative, that's where it's going to end. It's going to pull it down to negative infinity, okay? So, and you remember it's just opposite. Okay, so two different things, right? Odd or even degree, positive or negative leading coefficient. Two things you got to consider. All right, so let's try some of these. Some examples. Okay, so for this first example, all you're going to give me what the degree is, what the leading coefficient is, and then after that tell me the end behavior. Okay, so identify. A will do the degree, B will do the leading coefficient, and you know, we really just need to know if that's positive or negative for leading coefficient. And then C, we're going to indicate the end behavior. From that information. Okay, and this is ultimately what, if you get this memorized, if you learn this pretty quickly, it'll make this unit so much easier. Okay? All right, are we ready? F of x equals 2x cubed plus 6x minus 7. 2x cubed plus 6x minus 7. Okay, so A, we're going to do the degree, and I'm just going to go D for degree. Okay, degree again is the biggest power. What's the biggest power there? 3. Okay, which, am I thinking they're positive and negative or odd and even? Odd or even. Okay, so it's odd, so I know ultimately my end behavior is going to be opposite. Okay, then I'm going to look at what is the leading coefficient. What's the leading coefficient? Just give me the answer to that. What is it? 2. Okay, am I thinking positive, negative, or odd or even? Positive or negative. Okay, this is positive. Okay, so here's what I'm thinking. Odd here, odd, positive. Okay, with odd it's doing opposite. If it's positive, it's going to end high. Okay, that means it had to start low. So we're going to say for the end behavior, EB for end behavior, it's going to start low, end high. All right, let's do another one. Number 2, y equals negative 6x to the 4th plus 5x cubed minus 2x plus 1. Okay, so the 2 important things here. What's the degree? What's the biggest power? 4. Okay, am I thinking odd even or positive negative? Odd even. That's even, right? And then I know even does the same thing. It's even. It goes high, high, or it goes low, low. All right, then I'm going to look at my leading coefficient, and its leading coefficient is the number in front of that x to the 4th, which is negative 6. Am I thinking odd even or positive negative? Negative, right? Okay, so this is even, this is negative. Got to know which part I apply to which, right? Okay, then if it's negative, what's it going to do? Down, down, low, low. So my end behavior, low, low. It's going to start low. It's going to end low. It might come up and do some little twists and turns in there, but ultimately it's going to start down at negative infinity. It's going to end down at negative infinity. To the left, it's down at negative infinity. To the right, it's down at negative infinity. That's what that means. Okay. Number 3, h of x equals 2x cubed plus 4x to the 6th minus 6x plus 5. 2x cubed plus 4x to the 6th minus 6x plus 5. Okay, so we're going to try to trick you, but we're not going to be fooled, right? What's the degree on this one?
6.
It's 6, right? So they didn't list it in order, but you just got to pick the biggest one. So the degree is 6. Odd even or positive negative?
Odd even.
Odd even. So this is what I'm thinking. This is even. Okay, now, leading coefficient. What's the coefficient in front of the x that has the 6 on it? 4. Odd even or positive negative? Positive, right? Okay, so it's even positive. What's the end behavior? Does even do the opposite thing or does it do the same thing? Does the same, right? Since it's positive, it's going to go high, high. So again, it's going to start high. It might come down and do some little twists and turns, but then it's going to end high. It has to. That's what the end behavior means. Okay, one more of these. G of x equals 2x plus 1 minus 6x cubed minus 5x to the 5th. Okay? Kind of tricky, right? But we're not fooled. What's the degree? 5, right? Biggest power is 5. Odd. That's what I'm thinking. Odd. Odd degree. We've got to figure out a way to remember that. Some people get this backwards. Leading coefficient, in this case, negative 5. I'm not thinking odd on that. I'm thinking negative, right? So it's an odd, negative. Odd does opposite. Negative ultimately wins. That means the end has to be down, so it's got to start high. High, low, right? All right, I'd like to see scale of 1 to 4. 1, I totally do have this. 4, I totally don't. Tell me where you're at, please. 1 to 4. So you don't? What do you do?
I thought 4 was.
No, 1 you do. 1 you do. 1 you do. Jason? Okay, so, all right, we're going to then continue to kind of examine this in the next example. It's a little different type. From the graph now, you're going to tell me from the graph, oops, this is supposed to be Oh well, I'll just write example again. You're going to tell me, is the degree odd or even? Okay, so you're going to tell me, is it an odd or even degree? See if I can write. You're going to tell me, does it have a positive or negative leading coefficient? And then it's going to ask you to justify your answer, which we'll do based on the end behavior. Okay, so we're going to use the end behavior, so we're going to kind of go backwards now. We know the graph. Tell me then what the degree and what the leading coefficient had to be. All right, so number 5, if this is the graph, this is the graph. Okay. Odd or even degree? Even degree. So we'll say the degree is even. LC for leading coefficient? Positive or negative? Positive. Okay, which I'm just going to do a plus. How do you know that? Because it was high, high. So that's the justify. When it says justify, you'll just say it's because it was high, high. And that's the only way that could happen is if you had an even degree and a positive leading coefficient. Now, one other thing I just want you to examine, you're not going to have to do this necessarily, but you said even degree. Do you know, could this be a squared graph? No. The smallest the degree could be actually would be to the 4th. If you count the number of zeros, that's the smallest that degree could be. So 4 zeros there, as well as kind of what they call these turning points, these little relative extrema. There's no way that could be a quadratic, right? So we know it has to be at least a 4th degree. Something we're going to want to look at for the future, okay? All right, number 6, what about this one? Here's the graph. I don't want to talk about it too much because it'll give away the answers. All right, Jedrick, can you tell me on this one, is the degree odd or even? Odd. You guys agree? Okay. What do you think? Do you think you got the leading coefficient on this one? These are a little trickier, but you think it's negative. What do you guys think? Is that right? Yeah. Okay, because the end behavior, so this is the justify part, because the end behavior was started high, ended low. It was high to low, and the way that happens is if your leading coefficient was negative of an odd degree, right? Okay, and could this one be a 3rd degree? I got 3 zeros, I got 2 turning points. Could it be 3rd degree? Yeah, it could. You could have the little twist and turn. What's that? Yeah, you can count the zeros. That's the, if I have 3 zeros, then my degree has to be at least 3. Has to be at least 3. It could be actually even be higher, but if I was looking for the smallest that it could be, it had to be at least 3. Couldn't be a 1st degree, right? A line. The lines actually follow these rules too for the odds. Lines would be an odd degree. They follow the rules, but we typically go with the cube for our parent graph. All right, last problem here, little different example. I want you to write a polynomial. Write a poly. Can we just do poly period? Write a poly with end behavior. So do the W slash behavior. On the left, f of x goes to negative infinity, and on the right, f of x goes to infinity. Okay? There's a whole bunch of answers for this. You just have to make sure you get the right degree and a leading coefficient that would work with that. Okay? So what do you think it means that on the left it goes to negative infinity and on the right it goes to positive infinity? How have we been saying that all along in these notes? starts low, ends high. Okay, so what kind of function starts low, ends high? What kind of degree? Odd degree. And if it's low, high, what should your leading coefficient be? Positive, right? So you can make up whatever you want. I want this, my odd degree, to be to the 5th power, and I want my leading coefficient to be 10. It really doesn't matter. You make it up. After that, just make sure you don't go above x to the 5th, right? So you could go 2x cubed minus 3x squared plus 1. All the rest of the terms don't really matter, as long as my biggest power is odd and my leading coefficient for that is positive. Yes?
Does it matter how many terms?
Other terms, no. In fact, you could just write 10x to the 5th. That would be fine. Okay, so again, just the biggest power's got to be odd. You got it, Katie? What was your question? Because I'll bet other people had it.
Well, I made my 10 negative, so I'm just confused.
Okay. The left, it goes to negative infinity, means that out over here it's down at negative infinity. To the right it goes to positive infinity. Over here it's going to positive infinity. Again, it could do a bunch of little twists and turns in between. We don't know. But if it's low to high, that's a positive odd degree. Positive leading coefficient. Okay? So number 8, we're going to abbreviate here. So again, we're going to write a poly. Can you just go dot, dot, dot? So it's going to be write a polynomial with n behavior on the left. So just go on left. Let's say goes to, Melanie, we're just making this up. Do you want it to go to positive infinity or negative infinity?
Positive.
Okay, so on the left it goes to positive infinity, and on the right, Nick K, what do you think? Where do you want it to go? Okay, so on the left it goes to positive infinity, and on the right it goes to negative infinity, and you get to make it up, so there's an infinite number of answers. Okay, that could be right. I'm just going to look at that first term, right, or the biggest degree. What should your degree be if on the left it's going to positive infinity and on the right it's going to negative infinity? If it's doing opposite things, it should be odd, okay? And then which one basically started high, ended low? A negative, right? So again, as you write it, whatever you want it to be, you need your leading coefficient to be negative, and you need your degree to be odd. This answer's fine, right? But whatever you want, okay? Negative leading coefficient, odd degree.